Breaking news, Ukraine has destroyed Russia's Iskander missile system in just 30 minutes, causing an estimated $5 billion in damage.
At 3:41 a.m., the first Ukrainian drones crossed into the airspace above the Iskander missile maintenance site near Bryansk. There was no warning siren, no prior escalation, only a sudden shift on radar screens as 18 to 22 low-altitude UAVs appeared almost simultaneously, flying below 40 meters, moving slowly at under 120 kilometers per hour, and blending into terrain clutter. The drones did not head toward missile storage bunkers. They did not aim for hardened launch shelters. Instead, they moved directly toward the maintenance zone, where Iskander systems were temporarily exposed. At that moment, the base was in a routine overnight service cycle. 3 Iskander M launchers, each weighing more than 44 tons, were offline for inspection. Fuel lines were connected, cooling systems were open, launch rails were unsecured. Less than 40 meters away, 4 transloader vehicles sat parked in the open, each loaded with warheads weighing between 480 and 520 kilograms. One drone broke formation and descended sharply toward a cluster of support vehicles beside Hangar 2. The explosion that followed was not large in scale, but it was extremely violent. The blast occurred at close range, inside a confined service area filled with fuel lines, pressurized systems, and exposed hydraulic equipment. The initial detonation produced a short, dense fireball that expanded rapidly before collapsing inward, generating intense heat and pressure rather than wide-area destruction. Thermal sensors later recorded temperatures exceeding 2,000 degrees Celsius at the point of impact. Overpressure waves propagated outward across a radius of approximately 200 meters, rupturing hydraulic lines, collapsing auxiliary power circuits, and knocking multiple support systems offline in seconds. The facility itself remained standing. The system inside it did not. 2 transloader vehicles were immediately disabled. A third suffered structural damage severe enough to prevent rapid repair. One Iskander launcher was knocked out of alignment. Its launch rails warped beyond field-level recovery. Electrical power across the compound flickered for roughly 12 seconds, freezing surveillance feeds and delaying alarm synchronization at the worst possible moment. To Russian command, early damage reports suggested a limited strike. The facility had not been destroyed. Missile stockpiles were intact. From a distance, the incident looked contained. That assessment was wrong. The strike had been timed precisely to coincide with a narrow maintenance window of roughly 12 minutes, when launchers were unfueled, safety systems were bypassed, and even minor damage could cascade into operational failure. Ukraine had not attempted to destroy the Iskander systems outright. It had targeted the moment when disruption would cost more than destruction. Within 45 seconds, Panzer S-1 air defense batteries were activated. Radar sensitivity was increased. Crews were ordered to prepare for follow-on drones, focusing their attention upward toward the sky. By the time Bryansk shifted fully into defensive posture, the strike had already achieved its purpose. This was not an isolated attack. It was not reconnaissance. It was the opening reference point of a larger operation. While Russian defenses locked onto Bryansk, stabilizing damaged equipment and scanning for a second wave, the main sequence was already unfolding far beyond the region. Subscribe and comment below with your thoughts. At 3:46 a.m., while Russian crews at Bryansk were still stabilizing damaged systems, radar screens across Kursk and Belgorod began lighting up almost simultaneously. This time, the pattern looked different. Instead of a small, focused penetration, operators detected a rapid bloom of aerial contacts spreading across multiple sectors at once. Within seconds, radar plots showed more than 90 low-altitude targets drifting in from different bearings, flying between 35 and 60 meters at inconsistent speeds, with signatures that appeared heavier and more aggressive than those seen at Bryansk. To Russian air defense crews, this looked like escalation. There was no pause for deeper analysis. Panzer S. 1 batteries snapped into full combat mode. Longer range systems were elevated. Fire control radars locked on. Missiles began leaving launch rails within moments. Each interceptor cost between $140,000 and $160,000. In less than 6 minutes, air defense units across Kursk and Belgorod had fired off the majority of their ready missiles, burning through tens of millions of dollars worth of defensive munitions against targets that showed no signs of breaking formation. What Russian crews were shooting at were not attack drones. They were decoys. Ukraine had flooded the airspace with Corvo-type UAVs, each costing under $1,000. Broadcasting signatures deliberately tuned to resemble heavier strike platforms. The decoys did not evade radar. They invited engagement. Every launch forced Russian systems to commit tracking channels, fire control solutions, and interceptor stocks. As radar operators focused upward, the real movement happened lower, beneath the clutter created by missile launches, radar sweeps, and expanding debris fields. 22 to 26 strike drones slipped through at altitudes under 45 meters, using terrain masking and industrial structures to stay hidden until the final moments. Their targets were not missile launchers. They struck fuel distribution points, auxiliary power nodes, and reload staging areas supporting Iskander units in the region. One drone hit a secondary fuel storage zone, triggering a confined but intense explosion that drove internal temperatures past 2,100 degrees Celsius and forced an immediate shutdown of reload operations. By the time Russian commanders declared the situation under control, the damage had already been done. Several Iskander units were intact. They were also unusable. Fuel flow was interrupted. Power systems were unstable. Reload cycles were halted indefinitely. Ukraine had not attacked Russian air defenses head-on. It had forced them to exhaust themselves, overstimulating sensors, depleting interceptors, and locking operators into a reactive loop they could not exit. As Kursk and Belgorod reported success against the air threat, a far larger signal spike was already forming to the south. The defenses were still standing, but they were hollowed out. Subscribe and comment below with your thoughts. At 3:57 a.m., the focus of Russian air defense shifted south to Rostov. Unlike Bryansk or Kursk, Rostov was not a forward site or a secondary hub. It was one of the largest logistics and reload centers supporting Iskander units along the southern axis. Fuel, warheads, and transloader vehicles were concentrated here. Losing Rostov would not just delay launches, it would interrupt the entire supply rhythm. Local commanders believed they were ready. Radar sensitivity had already been increased following the earlier attacks. Engagement protocols were loosened. Crews were instructed to prioritize speed over confirmation. The expectation was simple: nothing else would get through. Less than 40 seconds later, that assumption collapsed. Radar screens filled with targets. Between 70 and 80 airborne objects entered the Rostov sector almost simultaneously from 3 directions. Altitudes varied between 30 and 70 meters. Speeds were inconsistent. Radar signatures overlapped and merged, creating what operators later described as noise rather than an organized attack. Pantsir S-1 systems can reliably track roughly 24 targets at a time. Rostov was facing more than triple that number. Fire control computers began cycling priorities, repeatedly dropping one track to chase another. Operators launched interceptors anyway, firing into partial solutions and degraded locks. In under 4 minutes, more than $18 million worth of defensive missiles were expended into the night. The sky above Rostov was busy. The ground below it was exposed. While decoys pulled radar and guns upward, 28 to 32 strike drones approached low and fast from the east, using rail yards, warehouses, and industrial structures to mask their final approach. Their targets were not launchers sitting in shelters. They aimed for the center of the system: fuel storage, transloader staging, and reload infrastructure. The first impact struck a pressurized fuel reservoir holding nearly 200,000 liters of propellant compounds. The explosion was heavy and sustained, feeding on confined fuel rather than dispersing outward. Internal temperatures surged past 3,100 degrees Celsius, igniting adjacent storage lines. 7 seconds later, a second strike landed. This time, the blast did not peak once, it cascaded. Shockwaves fractured reinforced walls. Hangar doors tore free. Fire spread along connected fuel channels, triggering a chain reaction that propagated across the facility. Sensors recorded continuous detonations for more than 40 minutes, long after the drones themselves were gone. Inside the compound, 6 to 7 Iskander M launchers were rendered non-operational. 8 to 9 transloader vehicles, essential for missile reloads, were destroyed where they stood. Hydraulic systems vaporized. Electrical control units failed simultaneously. By 4:02 a.m., Rostov had stopped transmitting coherent status reports. Power was intermittent. Communications dropped in and out. The logistics artery feeding multiple missile brigades was no longer functional. This was not a symbolic strike. Rostov did not fall because its defenses were weak. It fell because they were overwhelmed at the wrong moment. Ukraine had not tried to defeat Russian air defenses. It had buried them under volume, forcing systems to fire faster than they could think and react faster than they could adapt. As smoke climbed thousands of meters into the sky and thermal signatures lit up satellite feeds across the region, one fact became unavoidable. The southern missile network had lost its rhythm, and while Russian commanders tried to assess the damage, another defensive node, far more heavily protected, was already about to face the same problem. Subscribe and comment below with your thoughts. By 4:01 a.m., Russian command attention shifted decisively south to Krasnodar. Unlike the previous sites, Krasnodar was not just another logistics hub. It sat beneath one of the densest electronic warfare umbrellas in the region. Multiple layers of air defense were integrated with high-power jamming systems designed to deny guidance, disrupt navigation, and blind incoming drones long before they reached critical assets. Commanders believed this was where the line would finally hold. As early warning reports from Rostov deteriorated, Krasnodar's electronic warfare units were ordered to escalate immediately. Krasukha 4 systems surged to maximum output, flooding wide sections of the spectrum with broadband interference. Within less than a minute, signal density spiked by nearly 70%. GPS reception collapsed across a radius of more than 50 kilometers. To Russian crews, it felt like sealing the battlefield inside an invisible wall, but that wall had a flaw. The intensity of the jamming began to overwhelm Krasnodar's own sensors. Radar returns multiplied and folded back on themselves. Noise reflected into tracking arrays. Fire control systems struggled to separate real targets from their own emissions. Instead of going dark, the fortress became loud, too loud to interpret what it was hearing. Into that noise came the next wave. 30 to 35 low observable drones, constructed primarily from composite materials with minimal metal content, entered the region at very low altitude. Their radar signatures fell below 0.01 square meters, placing them beneath reliable detection thresholds. Rather than fighting the jamming, they exploited it. These drones were equipped with passive guidance systems designed to home in on electromagnetic emissions. The stronger the jamming signal became, the clearer their navigation reference grew. What had been intended as a shield now acted as a beacon. At 4:04 a.m., the first drone crossed Krasnodar's perimeter without triggering a confirmed track. Seconds later, impacts followed across the staging area. 3 Iskander M launchers were struck while parked nose to tail, engines idle, cooling systems exposed. The explosions were compact but severe, driven by proximity to hydraulic reservoirs and control electronics rather than large fuel stores. Thermal sensors recorded localized spikes exceeding 2,800 degrees Celsius. Hydraulic fluid ignited. Electrical control units failed simultaneously. Nearby missile handling vehicles began burning through their structural frames. 6 transloader vehicles were disabled in under a minute, their load paths destroyed before crews could react. Communications collapsed almost immediately. Fiber optic lines overheated. Backup radios drowned in interference. For approximately 14 minutes, Krasnodar disappeared from the regional command map. Status updates stopped. Coordination failed. What had been designed as the strongest defensive node in the network had effectively blinded itself. This was not a failure of hardware. It was a failure of assumption. Russian planners had believed that increasing electronic pressure would always improve survivability. Instead, the escalation removed their own ability to see, track, and prioritize threats. By the time jamming power was reduced and sensors began to recover, the damage was already irreversible. As smoke settled over the base and emergency crews struggled to regain basic control, one conclusion became unavoidable. The electronic shield had not been penetrated. It had been turned inward. With Krasnodar offline, only one major stronghold remained untouched. Crimea was next. Subscribe if you want to see how electronic dominance can collapse in seconds when the assumptions behind it are wrong. Comment if you think jamming still guarantees protection. By 4:10 a.m., Crimea had become the final intact node in Russia's missile network. For years, the peninsula was treated as untouchable. Its defense relied on density rather than any single system. Overlapping S-400 batteries, Tor-M two-point defenses, coastal radar, and continuous patrol coverage. The assumption was simple. No gap could exist because everything overlapped. The opening did not come from a mass strike. A single F-16 Block 50 entered low along the coastline, flying below 45 meters, masked by terrain and sea clutter. It was not there to attack ground targets. It was there to disrupt the defensive picture. At 4:12 a.m., electronic warfare pods activated, injecting focused interference across multiple radar bands. Seconds later, two AGM-88 HARM missiles launched, homing in on active radar emissions. Russian crews faced an immediate choice: stay online and risk interception, or power down and lose visibility. Several emitters went dark, others reduced output. The layered defense did not collapse, but it fractured. That fracture was enough. Moments later, a dozen UAV decoys entered inland, drawing fire from autocannons and short-range interceptors. Defensive attention shifted inward and upward, following false targets already expected after earlier attacks. While that engagement absorbed focus, 6 Neptune cruise missiles approached from the Black Sea, flying below 5 meters, hidden by wave clutter and curvature. Their paths converged on Hangar 12, the central staging site for the Crimean Iskander group. At 4:15 a.m., impacts struck in rapid succession. The hangar was breached while 6 Iskander-M launchers sat fully loaded, fuel lines connected, and reload cycles active. The explosions were not wide, but they were intense, feeding on confined fuel and hydraulic systems. Temperatures spiked beyond 3,200 degrees Celsius, triggering secondary detonations inside the structure. Within minutes, 5 transloader vehicles were destroyed, and the Crimean missile group ceased coordinated operations. The fortress had not been overwhelmed. It had been opened at the wrong moment. Subscribe if you want to see how timing defeats even the densest defenses. Comment if you still think Crimea was ever truly untouchable. By 4:25 a.m., the operational map no longer resembled a functioning missile network. Bryansk, Kursk, Belgorod, Rostov, Krasnodar, and Crimea were all reporting partial or complete loss of Iskander readiness. What connected these sites was not geography. It was timing. From the first drone impact to the final detonation, the entire sequence unfolded in just over 30 minutes. Across 5 regions, an estimated 18 to 22 Iskander-M launchers were rendered non-operational. More than 24 transloader vehicles, the backbone of missile reload capability, were destroyed or damaged beyond field repair. Fueling points, maintenance bays, and power nodes were hit simultaneously. Replacement timelines were no longer measured in days or weeks, but in months. Some components required factory-level reconstruction. Initial damage estimates placed material losses between $4.2 and $5.1 billion. But the financial cost was not the most important outcome. More damaging was the pause. Missile brigades that had been prepared for sustained launches were forced offline. Command and control nodes struggled to re-establish clean data links. For several critical hours, long-range strike capacity across multiple sectors was sharply reduced. This result was not achieved through overwhelming firepower. Ukraine did not destroy every launcher. It did not need to. Instead, it attacked the system's rhythm: maintenance, refueling, logistics, electronic defense, and command. Never the same layer twice in a row. Russian defenses responded each time. They simply responded to the last problem, not the next one. When the smoke cleared, the most important damage was not what burned on the ground. It was what stopped moving in the background. Launchers stood idle. Logistics froze. Decision cycles fractured. The operation did not rewrite the rules of war, it exposed them. Modern conflict is no longer decided by who has the largest arsenal, but by who understands timing, procedures, and vulnerability better. Steel was not defeated by more steel. It was outpaced by coordination. Subscribe for more breakdowns like this. Comment below. If this can happen in 30 minutes, how many assumptions are still standing simply because they haven't been tested yet?